Okay guys, today our topic is going to be on gradient descent. Yeah, and this gradient descent teaches us how model learn. Yeah, so let's just dive into what we have here today. The gradient descent is an algorithm that uses derivative to minimize a function, often called loss or error. That's in machine learning. When machine learn, this gradient descent is often used to minimize losses or errors during the prediction. So now we're going to dive into the calculation because everything we're going to be doing here is the mathematical aspect of how machine learns. Yeah, so let's go to what we have for today. First of all, we're going to be writing out the formula for this gradient descent. Let's say W being our weight, let's put N under is equal to W, let's put O under minus alpha multiplied by the L over the W. Okay, most people will be asking me why I wrote this formula this way, but this is the formula for calculating gradient descent. That's the lowest point of a function. So let's continue. This W now means the weight. W now is the weight, which means this is the new weight. This N under now means new. This is old. The new weight and the old weight. Okay. Why this alpha here now means learning rate. Yes, this alpha means the learning rate. Why the L over the Q, the L over the W now is a derivative of the loss function. Of the loss function. So let's dive into solving examples on this. Let's try to see and try to understand how machine learns using this gradient descent. Remember, the entire concept of the gradient descent talks about reducing a function, that's finding the lowest point of a function. So let's say example. Okay, example number one. Let's say given the loss function, okay, where given the loss function, let's define the loss function. That's L of W is equal to W minus 3 raised to the power of 2, comma, where the learning rate which is alpha is equal to 0.1. Okay, so given the loss function, this function is given where the learning rate is alpha is 0.1. What will be the lowest point of this function? So that's what they are trying to ask us. Remember, the entire concept of gradient descent talks about finding the lowest point of a function. So let's dive into solving the example. First of all, now let's look for remember, we're given this function is equal to, using our normal basic knowledge of calculus, we're going to know that L prime of W is equal to 2 brackets w minus 3. Okay, where we get to multiply it. Okay, sorry, 2 times 3 will now give us 6 at this point. Okay, here our w is 0, that's lw prime is equal to minus 6. Okay, and this lw prime is also equal to the L over the W. Remember, we're differentiating L with respect to W in this equation now. We're differentiating L with respect to W. So the L over the W now will be equal to minus 6. Okay, let's dive into this formula now. Let's use this formula to get the gradient descent of this particular function. Let's get the gradient descent of this particular function. So remember, we're looking for the new weight. Wn is equal to wo minus the alpha multiplied by the L over the W. Okay, this one remains the same. Wn is equal to, remember, W naught now is 0 because we are not given. At this particular point now, we substituted 0 into this equation. That's why we got minus 6. So W is not given. So remember, it's the old weight. So it was not given in the question. So we are looking for the new weight now. So this one will be equal to 0 minus the learning rate, which is, we got the learning rate here to be 0.1 multiplied by the L over the W, which we got here is minus 6. So that means Wn is equal to minus 0.1 times minus 6. Wn is equal to 0.6. So that will be our final answer for this particular question. So the lowest point of this function is 0.6. Okay, so let's try to find another one, number 2. Okay, I would like you guys to find another, that's the lowest point of this particular function, and let me write down the question. Okay, given so I would like you guys to find the lowest point of this particular function. That's using gradient descent, the formula to find the lowest point of this function. You can comment it down at the comment section.